These techniques could be very powerful for taking us to the next stages of applying biology to solve some of the world's problems.
This was Craig Venter, who pioneered the field of synthetic biology by creating the first synthetic bacterial cell back in 2010 with a completely man-made DNA made from scratch. He also led the scientific mission of human genome sequencing that revolutionized science.
Hi, we are your hosts. I am Prakhar.
And I am Akanksha, and we welcome you to a roundtable episode with Team iGEM Vilnius-Lithuania. We are happy to introduce our guests Greta and Goda from iGEM Vilnius-Lithuania.
Hi, thank you for having us. My name is Greta. I'm a neurobiophysics student at Vilnius University. I actually used to study art for some time, but decided to switch to science. And in our team, I'm responsible for science communication and human practices.
And I myself am Greta. I'm studying medicine at Vilnius University, and in iGEM, I am the team lead of Vilnius-Lithuania team, and I am working mainly with human practices.
We welcome you both to Synverse. Thanks for joining us in this episode.
So, Goda and Greta, as iGEM is all about addressing problems around the world with synthetic biology, so can you tell us what problem is your team addressing this year?
This year, we are focusing on a tiny and yet dangerous protozoan, Entamoeba histolytica. The species causes infectious disease amoebiasis, also known as amoebic dysentery, and it infects around 50 million people worldwide and causes up to 100,000 deaths every year. That makes it third deadliest protist-caused infection in the world. So, majority of cases occur in countries like India, China, and parts of South America. People get contracted with pathogenic Entamoeba species from contaminated water and food in places with poor sanitation. The disease brings various symptoms, from mild ones appearing as diarrhea to abscess, infections, and it could even lead to death.
Moreover, about 80 to 90% of the infected face no symptoms but can transmit the disease to other people who might be affected and face intricate complications. Such trade creates favorable circumstances for the worldwide spread of the Entamoeba histolytica.
I must say that your team is actually addressing a big health issue this year. So can you tell us how is your team aiming to solve this problem? And where does synthetic biology play its role?
We decided to look at our problem holistically and aim to target both prevention and diagnostics of invasive Entamoeba histolytica form if the prevention step while becoming infected is missed. The tools that we will create include a strain of probiotics and a rapid, low-cost, and most importantly, user-friendly diagnostic test. A therapeutic compound will diminish the virulence and viability of our target amoeba. We will achieve this by changing the genome of probiotic bacteria in a way that will make them produce a therapeutic compound called naringenin. It is a flavonone naturally present in plants and is known to be specifically toxic for Entamoeba histolytica and its virulence.
The test that we are creating will detect Entamoeba histolytica metabolic compounds present in a person's blood serum. By using SELECT's method, it will carry out evolution of single-stranded DNA and will pick out specific aptamers that interact with proteins of the Entamoeba histolytica. Such reaction will result in color change to make identification of infection easy, and in this way our test could be valuable not only for healthcare institutions but for in-home use as well. Both prevention and diagnostics parts are being modeled in silico by applying a combination of traditional methods and cutting-edge technologies in order to introduce possible improvements to the design systems.
That sounds really interesting. So, what was your inspiration for working on this problem?
Well, we had multiple brainstorming sessions like any other iGEM team, I suppose, and we had many possible topics that were ranging from bioremediation to programming recombinases, but finally we arrived at 3 different ideas to choose from, and one of our most fundamental criteria, I would say, was to pick that one idea that would be the most impactful. We saw such potential in the topic of amoebiasis prevention and diagnostics. And after thorough research, we found that current methods designed to diagnose amoebiasis are inefficient or even unavailable in the regions where this infection is truly widespread.
I would like to add that although amoebiasis is rare in Lithuania, after consulting with professionals working in the field, we found that there is a need for such detection tool as well, because identification of infection localization in the organism is a crucial step for the correct treatment strategy.
That's great. So how do you guys lighten up your mood when you are loaded with lots of work as a team?
Well, we work when we are loaded. I believe that thinking about our goal keeps us going. Of course, we have some breaks where we enjoy ice cream or cake together, and we went out several times to get to know each other. However, the majority of our time is spent working.
Yeah, and not to sound too workaholic, actually we joke around in our lab a lot. And since IT and human practices squads are often here, chit-chats and funny situations often happen. But I would agree that our team tries to stay focused, and we are planning to lighten up our mood after the giant jamboree.
Yeah, we can totally relate. So I assume till now you must have met a lot of teams. So, which team did you find the coolest among all?
It's a tricky question. We did meet a lot of teams, had many discussions and collaborations, but every team we talked to was great, and we are really grateful for the opportunity to meet people from all over the world, especially in the context of the pandemic, because we feel that we are traveling while talking to teams from different countries.
I would say all collaborations are meaningful, as the science world has to be open and collaborative. The fundamental progress happens when people work around together and try to reach the same goal. And it feels like our team is even bigger than the 13 people located here in Lithuania.
Yes, and I feel that's what makes iGEM unique. When different teams connect and contribute something useful to each other's project. So, how does your team visualize the world of synthetic biology a decade from now?
I believe that every team member has a slightly different picture of what synthetic biology will look like in the future. However, we all see its potential in making our world a better place, from dealing with environmental problems like pollution to helping treat various conditions. There are numerous ways to use synthetic biology where other disciplines are unable to help, and hopefully the wider public will become more open and less biased about this field in the future.
Your perspective is absolutely amazing. I think in future, synthetic biology will in itself carry an immeasurable worth.
Thank you so much, Greta and Koda, for your time, and best of luck for your team's project. So this was iGEM Vilnius-Lithuania, who aimed to combat amoebiasis with the iGEM 2021 project.
Come across this extensive use of SynBio and its importance to have an international competition centered around it. Have you ever thought about how it all started? What's the story behind it being one of the least known concepts to having the ability to solve some of the major problems of the world? To know more, stay tuned to our next episodes of SynWords.